So we defined that if function f of x has at the point x0 point extremum, we understand that extremum, which is minimum or maximum or inflection point. F derivative at the point x0, f prime of x at the point x0 equals 0. This is the main idea here. Now, how does it work? The first example. Example 1. The easiest one. For example, y equal x squared. And we want to know the extremum of this point. I have to calculate derivative of this function. Derivative y equal x squared derivative. And we can use the formula for derivative of the function. We have 2x. This is the first one step here. And the second step is this one. We have to define x when 2x equals 0. And x equals 0. I can cancel 2 here. So it means that f of x has an extremum at the point x0 point. Okay. That's all. We know that it is extremum. We don't know if it is maximum or minimum, but we know it has this formula, this function f y equal x squared. It has very special point when x equals 0. It is maybe it is minimum, maybe it is maximum, or maybe it is inflection point. So, next example. So, the previous example was very easy. Now we can consider a little bit more complex example. Example 2. For example, the given function x equal x cubed minus x. I want to know the extrema of this function. Extrema of this function. So extrema, they are known. The first one step, I have to calculate derivative of this function. So y prime of x equal x cubed minus 6 derivative. We remember that we can use the rule for derivative calculation for summation and subtraction, and we have to calculate separate the derivative of x cubed of each term here. And it gives 3x squared minus 1. The second step, we have to make equality 3x squared minus 1 equals 0. And the last one step, I can move 1 to the right side, it goes with sign plus, and we have 3x squared equal 1, x squared equal 1 over 3, and it means that x equal plus minus square root of 1 over 3. We have two answers here, x1 equal plus 1 over 3 square root x2 minus. So we know now that this function y equal x cubed minus 6 has true extrema, and we still don't know about their behavior. If they're what? Maximum, minimum, or inflection points. Okay, let's make the last one example for today. Example 3. For example, we have y equal logarithm ln of x plus x. And I want to know extrema of this function, extrema of the function. The under question. We have to make the same two steps. The first one step, we have to calculate derivative of this function, f prime derivative. I have to use the same rule because I have summation of two functions and I have to calculate derivative separately. I have 1 over x plus 1, and it means that 1 over x. And the second step, I have to make equality, define x's when this expression turns into 0. And it means that 1 over x equal minus 1 and x equal what? Minus 1. But is it possible or not here? Yes. At the first glance, we have extrema when x is minus 1. But we know that we can't calculate logarithm of ln of minus 1. It is impossible. For calculation and domain of this function of ln, domain of because domain of the function is from 0 plus infinity. So there is no any, we can say, even we have the 0 of this derivative of the function, we don't have the extrema of the function ln x plus 1, because the domain of this function is restricted by domain of ln of x of the logarithm. So sometimes we have this kind of pitfalls. So we have to explain, to define not only zeros, but if these we have to, they should know if this 0 if this x is belongs to the domain or not. Okay, I think it's enough for today, because currently we can find only extrema points, but we don't have ability to define the maximum it is if it is maximum or minimum. Next time we'll know how to define if it is maximum or minimum of the point. See you.